Let's continue system design. So last couple of classes we have learned a small part of the basic concepts. Okay. So today I am going to talk. So let's see how we are going to the build system. So while building systems, we have to follow some kind of principles, some kind of guidelines. I say, hey, I am going to build my house or build. So for building my house, we have to follow some basic ethics, basic guidelines, you can say, or you can say basic experience of the people which already have built lots of building, lots of house. So I can build my house. So generally I know a house required a couple of bedroom, couple of washroom, couple of halls, kitchen, everything. So that's a good idea, but these kind of building house already since a couple of years and years, our engineers, our old peoples are already build. If I am going to build from scratch or by myself, so why not I can take the learning of our existing engineers, existing people who have already built the house. Okay, so they guide us. Hey, what kind of challenges, what kind of a problem, what are the smooth way you can build? Because once we done our construction of building, lots of things we learn. How to talk to the builder, how to buy the materials, how to designs the floor, lots of things we learn after doing. That's great. But everything as a human, I cannot learn from doing myself. So why not good objective? Hey, clear is I am going to build my application. I'm going to design the system. So let's keep the similar kind of a house already someone built. So the basic first questions is in my mind, or you can go and ask your constructor builder, house builder, hey, you can build my house. So the house builder or constructor owner just ask one question: how you want your house? What kind of designs, or what kind of interior, or what kind of lots of questions they ask. One of the basic questions the constructor builder ask is, you have finalized any kind of your building architecture for that, whatever your land area, what are the height and width of your, and in this area which portions, what the size you allocated for your gate, what the size you allocated for your gardening, what the room size would be, what the number of room would be, how the communication between the different room happen, where the gate would be. So all these kind of basic questions may be asked. Okay, so this basic questions in the house constructor business industry say, hey, first you need one house architecture, so that our builder can build house according to your architectures. So similarly, like in our construction industry, for building any house, for building any business, for building any factory or something, we first must be finalize our architectures of my building. So in this architecture, they define the room size would be like this, the number of room would be the kitchen size would be the locations of my windows, locations of my toilets, washroom, and how these rooms are connected, how I can go to the my this room or my this room or my this room, all the communications, the locations, and every the width and size of gate, rooms width and size, everything. So generally in the our house architectures, everything for the layout perspective you have mentioned, your length of the plot or your land and width of the lands, and what length and width of each your bedroom, each your hall, each your kitchens, room, entrance, window, gate size, everything you means, where my stair goes, stair go from inside outside, where is my parking slots, where my gardening positions, each and everything's with a specific size, length, width, foot are mentioned. And once this architecture is finalized, I give to my house constructor builder, and house constructor builder is a responsibility to build the same house as mentioned in this your architectures. So for builder, your architecture make a guide, make a references. Hey, here I can start with this. Once your builder build the house, and you can notice whatever the your blueprint architecture on your paper you have, you can now leave, you can use same kind of gate, same kind of room, same kind of entrance, the same size, where the window defined, where the kitchen defined, where the stair defined, each and everything's now our builder can build for us. And this architectures maybe different lands, same architecture, same kind of house, same kind of building, builder can made. So this is the first and basic questions whenever in the software industries, when I am going to design any software, any system, first let's finalize our architecture. So this is the three conditions for starting, building, implementing any software system. First, you finalize, fix your architectures, what the architecture would be. In the case of software industry, architectures like simply like structures of your system. Structure means the number of modules, the number of component, number of subdivision, number of functions, how they are built, how they are interact to each other, what kind of technology, what kind of hardware, what kind of software, what kind of third-party tools you are going to, each and everything you are going to the finalize for your architecture. So look like in the construction industries, we are finalize our architecture first for my house, for my factory, for my company. Similarly, in the software system design, we first finalize our system architectures. So let's I am going to talk about the system architecture. This is the very first and prerequisite for any system which you are going to design. So as we discuss about the in the construction industries, what the architecture or the blueprint which are the available. Similarly, in the system architecture, this is also the overall structures of your an organization of a system. So lots of structure means lots of components and how they are organized to meet the system, to build the system. And generally structure includes your components, relationships, and interaction. Might be this system or interact to other system. So while defining your system architectures, you have to finalize all the components in this system would be okay, and also decide the relationship, how they are relate to each other, how they are talk to each other, how they are communicate to each other, and any this system or might be interact to the third party system, third component, overall something. So what the interactions, the interaction, relationships, and all the components you just identified and make overall structures in organization. So system architecture is nothing, just refer to the overall structures in organizations, systems and organization of your all the components and the relationship and the interaction. And it's also ensure that you can say system architecture also sometimes it's a very high level of designs of your system as well as you can say. So this also include our system architecture high level designs, including your technology choices, what the technology you are going to use, what kind of hardware you are going to use, what kind of software you are going to use, and what kind of networking or infrastructure you are going to the plan. So our system architectures contain the high level designs for the system, including all the relationship, components, interactions, and including your software, hardware, and the infrastructures where your application going to deploy, what are the locations, what you are going to the in premises, off premises, cloud enable or non-cloud enable. It's everything you have to finalize. So somehow you can say system architecture, a high level of your system designs. That's detailed out how our engineering teams, our implementation team is building, start developing this system. So for developing, let's say software engineer are going to develop, so they must know what the component I am going to build, what interface I am going to build, what the interaction we have to implement it, what kind of technology we have to use, what kind of database, what kind of hardware, what kind of technology, what kind of everything you as a system architectures you have to place. Even system architecture also you can say provide the kind of frameworks. Frameworks means architectures that help us, our implementation team can just follow the steps. First they have build the UI, first build the REST API with this interface, this database, this is schema, everything you can say. And this frameworks, so whatever the framework system architecture going to provide for the implementation team, and implementation team also from this framework understand your system behavior, functionality, as well as the performance. Even sometime you can say system architecture serve as a guide for your system designing, implementation, and maintenance. So your architecture, system architecture plays this guidebook for while the designing system, what the component you have to consider, while the implementation, how implements, and while maintenance, how our system would be maintained. So everything your system architecture pointed, highlighted, while implementation, all the detail, while the maintenance, how system going to be in maintenance phase, in the designing, what the key parameters, what the component, what the interactions would be. So overall system architecture play a very crucial role. You can say any good architecture play a very crucial role for building a system that's are scalable, maintainable, and efficient. If you want to build a system that is very efficient, scalable, maintainable, you have to focus on a good system architecture. Okay, so hope this make little bit idea. Just understand in the point of your construction build industries, where you first finalize your architectures, land, and then give to the builder, and builder on the land they are going to the build. So only you cannot give the, hey, this is my architectures, this is my architecture ready, and hey, builder, can you build them? You also give, allocate them where these are architecture going to build, what are the land, and maybe different region, you can say same architecture I can build here, same architecture I can build here. So our constructor builder can build same architectures or same house in the different region. Similarly, if you designs one system architecture, from using this system architecture, many system in the really you can build. After implementation, you can leave them, you can use them. So here system architect just like a blueprint, just like on a paper, just you finalize each and everything. But this is going to actual use once implemented. So here system design play a guidebook for the designing your system, for implementing, and even after implement, how it's maintained. So if you talk in the software industries, millions, lots are huge the way, because nowadays decades, more than couple of decades since our software industries are building softwares. So if you talk all the practices since last couple of decades, you can say our software industry is building the software, building a software, and years are years, our experience in building software industry is going to increase. Whatever the knowledge base we have, this is the maybe in 80s and 90s, whatever the software building, lots of we have a expertise and knowledge base. Similarly, 20 and near 2022, lots of software builds, and we learn lots of knowledge. Yeah, after 2010 and 20, lots of software build, lots of knowledge base we have. So nowadays in 2024, nowadays in current year, we have huge knowledge base, a huge number of reference architectures, reference patterns, reference style available. So we are not going to launch each and every patterns, architectures, style, but couple of which mostly while system designing we talk, I am going to cover. So here if you took the various kind of patterns and styles, because each industries, each domain, each engineering teams free to discover how they can build this system, build the requirement, build the software. But after the number of experience, the software industry is going maturing, they can find many system requirement, whatever the customer give us, lots of similarity, lots of commonality, lots of same requirement from the multiple industries, multiple requirements, authentication, authorization, security, scalability, the common. So for these, which are very common customer requirement, and every customer requirement need a security, need authentication, need authorization. So for those, already we have lots of experience to build such module. So why I am going to invent the wheel from scratch? No, we have to use our software industry's existing knowledge. This is my primary preferences. Whatever the customer you are going to design system, let's understand the customer problem. Once you understand the customer problem, and next our objective as a system design engineer is that for which industries, for which domain you are going to build system. In those domain, maybe healthcare domain, financial domain, telecom domain, medical domain, pharmacy domain, FMCG domain, any domain. Nowadays already your software running, lots of application is scalable, maintainable, highly available software already running. So our first objective, let's refer those architecture which already used by the system, used by the in this industry the customer. So if you are going to see, read all the reference document is specific to the customer industries, and then you find lots of the customer problem already similar, which existing system architectures are already implemented, already played. So we are going to build my system designs on the top of that, not from scratch. So sometimes you say reference architectures. Always refer particular industries, particular types of requirement. In rare scenario, you are going to design a system that is unique. That is no such you can say patterns and style available. But if you are still, you are going to build a very different domain, unique kind of a principle, unique kind of patterns. It's still the existing related business, related pattern still help you to think, to design your new unique problem and styles. So my preference is always we have to study reference architectures which already we have as a knowledge base for the software industries. So we are very thankful all our the previous software engineer, system design engineer, they have a play very good role. They have implemented and they have documented, they have designs, they have published those such architectures. Now we are just using them, we are just studying them and making our system on the top of that. So don't think from starting, just our responsibility. We have to know this is already somehow some pattern, some principle, some style already available to meet this customer requirement. If something, if let's say you find out maybe 10%, 20%, 30% your requirement match to the existing architecture, that's good. At least you save 30% times, and later 70% you can design on the top of that. So my preference is, as a software design engineer, we have to understand the reference architectures in the different domain, different. So instead of we are saying, hey, these are the architecture, sometimes I prefer all these various architectures, say this is the architectural patterns and style, because these are developed by different company, different engineer groups of company, right? So we should aware, we have to know these kind of architectural patterns and style exist to help us to build our system, right? So let's I'm not surely this is the only one session, not possible to cover lots of patterns and styles, but basic like you already hear the monolith architectures, or microservice architecture, or client server architecture, or layer architectures, or entire architecture, service oriented architecture, event oriented architecture, message oriented architecture, lots of kind of architectures available to build system. So as time permits, I am going to maybe talk couple of, not everything. My personal preference is just make curiosity for you that you have to explore lots of reference document. A good part in this software industries, all these architectural reference documents available on the internet. You don't just go to the Google and ask, I want to understand monolithic architectures. Every architecture document details you can find. Just we are give some time to the each architectural reference document. It help us. Once you aware these architectures, you feel very confident while designing any new customer requirements. You lots of things you already aware how you implement authentication, authorization, security, a high availability system, scalable system, fault tolerant system, cap. There are lots of things we know. So you are feel confidence and to support to offer very good scalable maintainable system designed to your customer. So existing knowledge, existing experience of the software industry, we have to take advantage. Okay, so for that scenario, let's today I am going to talk only one monolith, very brief, because whatever I am going to talk, each and everything, this reference architecture documents already available. Why I say reference? Because this is already available. Lots of application already built on the monolith architecture, and nowadays you can also think, you can also build, right? So let's talk what is monolith architecture. And nowadays in the terms of microservice architectures, these are comparing your microservice architecture. We many talks about the monolith architectures. So let's understand what do you mean by monolith architectures. So you can say monolith architectures is the software architectures pattern. Notice this is the software architecture patterns where single unit of code, or you can say monolith. Monolith means one component, one unit, one software, one function, or you can say contains all the necessary components, including the user interface, including the business logic, including the database logic, including everything that provide to complete your business functionality. So here monolith applications say, let's start building only one component or only one unit or only one module where I can build my user interface, where I can build my business logic, where I can build my database, where I can build my interactions, communication, everything. And this is the only one unit or only one component or only one software that's meet the complete customer requirement. Maybe here authentication, authorization, payment, enrollment, profiling creation, everything. Only one software component is sufficient, capable to meet the customer requirement. So such monolith means single unit. Yeah, only one unit. One only you can say. Monolith means single unit. Maybe you can say single means single unit, a single module, single software, single component, single deployment component, you can everything. So if you talk the scenario in which places you are going to use the single module to serve all the customer requirement. Okay, so here say monolithic architecture is suitable for if your application is a small or medium size application, or maybe sometimes this is also very fit nowadays. The prototype means sometime you want to get the customer confidence, you are getting the customer requirement, I want to build something high level, I want to show customer, or sometime you want to do the POC development, proof of concept. Hey, you have to visualize something, this can be built. So whatever you thinking on the as you're designing this paper or the in minds, it is a good option. You can do POC, proof of concept. Just let's build them, deploy them and test them. So in those scenarios, this monolith architecture is very fit, because you just build only one single modules, and whatever the basic core idea, core algorithm, core functionality you want to build them, deploy them and test them. So any reference architecture, I cannot say good or bad. Maybe monolith is microservices architecture, service oriented and REST style, anything. My preference is each and every is the knowledge for our system engineer. For me, monolithic architecture also is knowledge base, and sometime this knowledge we can use. You can say understand these all the reference architectures, maybe monolithic, microservices, service oriented, any serverless computing, everything look like a one tool for the software engineering. As a software system engineer, I have a one tool, I have another tool, I have another tool, I have another tool, we have lots of tools, and this tool I am going to apply with my intelligence. Hey, this tool is fit for this situation, this time, this use case. This tool is fit for here, this tool is fit for here. Notice nowadays any mechanical or electrical engineer come, or any former any kind of engineers come in the system, they have a lots of toolbox. Some is small tools, some big tools, some bigger tools, some bigger tools. So you can ask if why these all kind of tools they have. Yes, these tools, they sometimes very small tools are used for the small places, big tools for the big places. So you can understand this, all the reference architectural patterns and style is one engineering tool for us. This tool is not fit for every case, every situation, everywhere, but as a common sense, we are going to apply these patterns, practices in a specific case and a specific situation. That's common sense we engineer apply. Hey, this tool is fit for you. So let's understand all this as a simple one reusable tool, a component for you. Okay. Okay, sorry. Somehow I closed the window. So be ready to launch lots of pattern and practices or style in this IT industries. So we're discussing this monolith architectures also is a tool, and that tool is fit if you have a what I am doing, so something wrong happen. Okay, I pressed some wrong button, due to that which are the close. Okay, no problem. Sometimes something happen. That's it. So this one monolithic architecture, this is very suit for a small and medium size application. You are going to prototyping, or you are to completing your POC. And this application, you can say, if you talk such application, complexity of such systems is, you can say, relatively very low, and the development team is maybe small, maybe 1 or 2 or 3 team member can easily build such systems. So even if you are going to build this monolithic, also nowadays monolithic also can two kind of monolithic. One may be single code based monolithic architecture. That means you have only one single code, one big code where everything you retains. Okay, and this is considered as your single code based monolithic architecture. One is a modular monolithic architecture. Means ki this is the only one single component, but here they contains of different logical modules. Okay, logical modules, they are built separately, but they are designed, deployed as a considered as a only one single unit. So our monolithic architecture can be two form. One is you can completely write everything on a single code base. That's good. Someone, no, I am writing the separate business, separate logical division, subdivision, sub module or group, and then consider while the deployment, it is a single unit of my component or software. This is known as a modular monolith. So you can say monolith can be sometimes single code base or sometimes modular monolith code base. So if you talk about the single code base monolithic architectures, the entire application is built as a single code base where all the components including user interface, business logics, database access and residing in the same code base. This is generally any places where the small and medium sized applications are like discuss prototyping or proof of concept kind of things, where this single code base monolithic architectures play a very important role while the POC and prototyping. And if you talk some kind of architectures advantage disadvantage, so as mentioned, the architecture is only single code base, single database or single deployment unit, you can say. The development advantage: simple to develop, simple to test, easy to maintain, easy to understand and debug, because there's only one single code base, you can easily understand and debug the code. And the what kind of a problem with this architectures like monolithics? So scalability issue, tight coupling issue between the components and difficult to make any changes. So whenever you read any reference architecture, you have this reference architecture, some case it's work very fine, but it is not work fine or good for every cases. So somehow every system design architectures have some kind of advantage, some kind of disadvantage. Advantage means in which use case, in which scenario this tool is fit, but you are trying to fit in another scenario, another places might be it not fit. So nowadays what happened, while completing my system design, might be I can use started from one kind of architectures, customer requirement change, we can move to another, we can do. So understand, any one architecture is not fit or good for all the system designs, all the kind of customer requirement not meet. So each customer, each domain, each business have a different kind of requirement, different kind of situation, different kind of a demand. So depend upon the situation, depend upon the use case, we have to use the different architectural styles and patterns. So due to that, here is scalability problem, because if you want to really build very highly scalable application, might be this is not fit forever. Okay, so the most probably if we talk some case study where like Airbnb early started architecture as a monolith, but later they transition into the service oriented architecture, because they have going to think, hey, this architecture, let's say we start from the POC or prototyping, customer is happy, and then you start building the more application, more requirement, and later you find out, hey, this single code base monolithic architecture now is not fitting, let's go with the service oriented architecture. You can move on, transition you can happen later. So similarly, if we talk about Instagram in early architecture was a monolith. When Instagram started, they started with the POC, started with the prototyping. So generally, the any applications you are starting the new ideas, new business, something where POC or prototype, so that scenario your monolithic play a very role. And later part, there is no any hard and fast rule, hey, you can selected the one architecture, then you have to always be in the same architecture, you can move. So here's a lot later they adopt the microservice architecture as well. So Instagram nowadays are using the microservice architecture. Initially they started with as a single code based monolithic architectures. So for unique ideas, unique business, small POC, monolith architectures play a very good architecture, because they give quick overview to the customer. You can demo to the customer, you can show your idea, you can show your business value, hey, this would be in the future. So let's talk about the different types of monolith, like modular monolith. So here logically the application divided into this smaller independent modules with its own set of function and the responsibility. Generally, you can say, hey, UI I can build separately, business logic build separately, data conversation build separately. So logically, you separated build the different module, so that this is the separate UI team, separate logical backend team, something. Okay, and but still all the module as a part of one single code base. But they, once you build and deploy the code, we can build only one kind of a deployable component. So here somehow the application with the multiple loosely coupled feature, but this application again become a very large code base, large functionality, everything. This all kind of user interface, maybe your product information, maybe payment system, maybe risk rating system, everything is under only one deployment component. If you talk similar again kind of architecture, so here again single code base, single database, single deployment, but still logically separated with a separate component model, just for the development perspective, just for the implementation perspective, logically separated this. Again the same thing, this is the monolithic architecture, this is the very easy to develop, easy to test, easy to maintain, and this is all the traditional monolithic architectures still get the benefit for the single code base. But the only single code base, you can easily debug, you can easily just read the code one by one, you don't go to jump here and there to understand the function. Again this kind of a problem also they have, kind of again scalability issue, tight coupling between the components, because we have only one single deployment components. But if you note the industries, notice the LinkedIn, initially the architecture was the modular monolith. LinkedIn started as a modular monolith and separated the module into the different feature and services. Similarly, you talk about eBay architecture, is also started like a modular monolith and separated module for the different business and different component. So you can think lots of application initial day started with the monolith architecture as well as, right? So if you talk in general, any our you can say our monolith architectures, they have followed this kind of a basic architecture. That means the architecture is what the logical structures of your application, our systems. Okay, so here generally the architecture of my monolith is architecture pattern is the, you have defined your user interface, the interface that interact with the user and provide the requirement functionality to the users, and some business logics. Business logic is a component that contain the rules and processing govern all the business rules for the application, and some the data access, where the database component is responsible to accessing, storing your managed data. So generally any monolith or single code based application, they have defined the three high level of components, you can say user interface, business logic, and data access. And if you talk why I am going to do so much. See, if you generally monolith contain these user interface, business logics, and your database access. If you talk the advantage of overall monolithic architectures, best part here is the easier to development, because this is the very and simply fastest deployment, because they have only single unit you can go and deploy, and even the simpler to testing. This is the key benefit of your monolith architecture, easier to development, faster to deployment, and simpler to test. If you talk again the disadvantage, again problem, then again this kind of applications you cannot more scale them. Also problem about the maintainability, also problem about the flexibility. This kind of a system is very inflexible, very difficult to, hey, something I want to change, maybe only one code base, larger code base. If you are going to the change something, that will affect all multiple business, multiple components. So even this is the very any small change request come or any defect come, so this kind of application is very hard to maintain, because you are going to the change some global variable, some function that are used by the different places, different core business logic, that will again maybe one defect fixes impact some other kind of application issue as well. So these kind of challenges you face if you are thinking your system is a monolith. But sometime I don't want to more kind of a scalable application, I don't want to more maintainability or inflexible, because I want this is only for the POC, this is small application, this is not so large code base, so we can manage. So this disadvantage can be manageable if your requirement is very small size of project, small size of applications where you can think. Okay, even if you talk some more case study which are generally using the monolith architectures early days, and now they are transitioned to the different architecture. If you talk about the PayPal, if you go initial architectures, early architecture of the PayPal was a monolithic architectures, and where the entire application is built as a single code base. However, once company is growing, they had to refactor their architecture, and now they are more scalable microservice architecture nowadays PayPal is using. Similarly, I talk the eBay. In its initial architectures, early architecture, monolith architecture, where the entire application was built on a single code base, but company grow, they had to refactor their again the entire architecture, and now it's a scalable microservice architecture nowadays. Even similarly, you can talk about our Amazon. Amazon's also initially was the monolithic architecture, where the entire application built as a single code base. But once company grow, business grow, they have refactored the architectures, and nowadays your Amazon is the highly scalable microservice architectures application nowadays, right? So even if these are the applications which are started some monolithic, converted to the different microservices, but still lots of industries application using the monolith. You cannot say this is the not usable kind of architecture. Yes, if you talked about the Microsoft, the SharePoint is a good example. The architecture of the SharePoint is your monolith architecture, where the entire application nowadays is a single database. Similarly, Oracle Siebel is a monolith architecture, where the entire application is a single database. Similarly, if we talk about the SAP ERP example of the monolith architecture, the entire application built as a single modules. Similarly, you talk about the Salesforce. Salesforce is a CRM tool that is also in the monolith application. The entire application built as a. So I'm trying to say, generally all the application which you are going to build, that are not need to serve the huge customer base, large of the scale kind of points, right? So let's understand the customer nature. You are building one application. That application is specific building for your company top management CEO level. So in the particular organization, particular company, limited number of CEO subordinates or management role. So there is just no kind of benefit. You are going to the building highly scalable system. Might be monolithic is very suit for here. Just build monolithic application, single code based application, easy to develop, easy to test, easy to deploy. And you know ki this my application use base is limited customer, limited number. This is our system is capable, one database, one business logics, one code base is able to handle. So my preference is these are the tools. Many places, many applications nowadays is not available globally. All the applications, not the Facebook, not the Instagram, not the Amazon. And even you are going to design as any customer, that customer also not a play look like a very big, huge kind of a user base. Some you are going to build a specifics for the specific one company, and in the specific company, maybe specific department you are building. A specific department have a specific kind of roles of user. For those you are going to be building the software. So might be such a specific requirement, highly secure. You know the maximum number of user base can be this. So single code base or monolithic architecture, yeah, modular monolithic architecture play very important role. Nowadays, all the small user base, small number of functions, a small number of use case, surely you can go build with a modular monolith. Means you can separate business wise, but go with a monolith. So you cannot say monolith we cannot use. Monolith can use, but every places monolith cannot use. Because where you have to manage huge number of user base across the geographical location, huge number of volume data size, surely monolith cannot help us. But you know the specific customer you are designing this application, they have a limited setup user can be and limited data information I am going to store. So these information monolith, modular monolith can be can be best. Why you need to go different kind of architecture? No. So my here thumb rule for using any architectures, don't go with the architecture. You are building system for the specific customer. So look the customer. So this is the my preference choice. Whenever you are going to designing any systems, let's talk the your user loads. The number of user traffic can be, might be the particular system user traffic cannot be more than the thousands, more than the 10,000. Still monolithic is able to manage. So first always talk the concurrent user base. What number of, for which user you are designing. Such you are designing some very security domain application for specific industries. Might be this is not huge million of customer using them. This is maybe private some company for you are building them. And similarly next, this is the current concurrent user base you are talking. Means ki at a times you ask the number of concurrent user can access my system. Similarly, what number of data I want to manage? What is the volume size? What the number of data? If the data size is not too much high, I'm not going to think more different architecture. One database, one single applications is sufficient. So let's focus on the customer for which business, which requirement you are building. And many places you going to talk to the customer. Your customer might be with a limited user set, limited data set. So those scenario, you are limited concurrent user, limited data set, a limited business functionality. They just want to do kind of a workflow. Just I want to view all the approval of my systems as a particular management or particular security agency. You want to, hey, this is the one applications you are going to the build. This is the one high level of security agents. They need to verify. They can view all kind of pending item, view them, and after that they can approve them or reject them. This is a very high level of senior authority. They don't need. So you can just build one system application. This maybe read data from the different source of the applications, read data and display here. And this our security authority person can view and validate everything. Okay, they can approve or they can reject. So might be this is very simple application. You have to display all the particular profiles, risk detail here, and they have only two kind of functionality. One is the view all kind of profiles, and they have a two action, maybe approve them or reject them, or while rejecting they can add some comment. No information going to storage. Just again go to the third party applications where the information just update the status. So might be some kind of a small requirement where there is no use to build very highly scalable application. So monolithic is first. So let's think monolith architecture is the good for any small and mid-size applications, or any kind of prototype, any kind of POC, where you want quickly to deliver your software to the customer. Initial build, monolith play a very important role. So whatever the reference architecture we are going to study, we have to understand in which case, in which scenario this will fit. Don't try to fit every architecture in every state. So while monolith, you cannot say, hey, this is not scalable. They cannot manage the large user traffic. Yes, because we are not using such tool. This tool for the minimum number of user base, minimum number of data set, right? So where such requirement meet, I can use this monolith. Else I cannot. I have a different tool. I am going to the microservice. I am a highly scalable architecture, right? So let's think monolithic architecture is also very good architectures for a small set of business requirement, a small number of user base, and not so huge volume of data. You can easily build your application in the modular monolith architecture as well. As that's play a very good role, because you have easy to develop, easy to test, and easy to deliver to the customer. Hope this information is helpful for you. Thank you.